because somebody should finally let you in the house. Hi. Hello. Hello. All right, so let's kind of start this video a little differently. Not different-ree. Different-ree. Let's do it different-ree. This is RO number 36. We'll get over to that here in a minute. So, I did huge internet search last couple days. Looking for parts for a friend. He's got a pair of something or others that he's having all kinds of issues with. And one of the things we determined was his blocker was too small in kVA. So, wasn't enough kV. One of the things that we needed to buy for him was another one of these. And I felt lucky that I was able to even find it. God. So I put this order in with RF Parts, and I ordered 4 of these because they were supposed to be sold to me in sets. Let's see, what's the invoice say here? So, 88911 connector coaxial dynamics, set of 2, and I bought 2. And so I get this email from them, and it says, we only have 1 of these in stock. We'll be refunding you back your other $10. And we do not plan on restocking. What this is the special connector that goes to a like an 1 5/8" line section. Okay. Well, I need to build 2 sets of jumpers for my friend. My friend doesn't realize that all these parts are getting really hard to find. So I was able to get on the internet, and I've got 2 more sets of these coming from another guy. Thank God. This was the big find, in my opinion. Look at this beautifulness. This is the last one they had in stock. That is a doorknob. It's like a little baby. 15 kV. It's 500 picofarad. So we put 3 of these in a row, and all of a sudden you got yourself a really healthy blocker. I'm glad this showed up. I'm glad I was able to at least find 1. Would have loved to have found about 6 of them, but all these parts I got over here, all of them. I just wonder on the box. No part numbers. Okay. We'll figure that out here in a hot minute for my friend. And let's see. I want to show you a big blocker. All right, so this gentleman here bought this amp, and this supposedly has no talk time on it, which I'm like, cool, whatever. Let's make sure I tell you the whole story here. Okay, I drove this with a Texas Star modulator, new version in parentheses. The DEIs in it blew up. I want it done with HG2879Cs. All power wire upgrades, include new Anderson clips, solder on, fan made so it turns on immediately. I was talking with him earlier today. I said, hey man, it's finally your turn. We're going to do your amp. He said, give me a predicted budget. And I said, okay. Well, we're going to put about $300 and some worth of parts in this thing. Between the transistors, the wire, the solder, and so forth. I said, I'll charge you a couple hours of labor because it's going to take me a couple hours to do this box, do it right. Usually it works out to about 3 or 4 hours to do these mods. And I said, okay, so your budget's going to be this. And he goes, Oh, thank God, because I've got this, which was literally like twice my budget. And I'm like, wait a minute, hold on, did I say the wrong thing? I'm sorry, I meant, you know, and then I came up with a whole nother number. I said, bro, there's a couple things you never tell your amp builder. One, you never tell them that your budget's twice what the amp builder's quoted you for the work. And the other thing you never, ever, 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 ever say to your amp builder is, don't worry about it, just do it in your spare time. What that translates to every amp builder's brain is, okay, I'll agree to do it if I can do it in my spare time, which might take 2 to 3 years. Moral of the story is, yeah. Okay, let's take this lid off. And let's focus in on this coaxial connector here. Do any of you guys see a problem? Looking specifically in this area here versus that area there. This is on the input side. Normally where we see this is on the output side. The connector gets hot and it slips back in. It makes really shitty connection, and then everything on the inside of the amp blows up. He was not lying when he said that this thing went up in flames of glory. I mean, look at this. That's all from this one. And people think I'm crazy for wanting to put 2 watts in here. This little 2 watt or 1 watt resistor. Look at this thing. Look at the mess it made. So when this goes down like this, we've got this set of transistors that might be okay, but this set's dead. This set most definitely dead. And this is another version of Flambango. This combiner here, we might be able to save it. It's only been flambéed on one side. This one over here on the other side, though, is a complete loss. Hopefully we can find another one of these around here, or I just might have to break out the old mag wire and rewrap it by hand. Not a big deal. I want to put new, different, actually held in with screws and nuts, hardware, coax connectors. Now, I want to just put this out there into the digital ether. The Texas Star Sweet 16 is like one of the most venerable amplifiers, in my opinion, over the decades now. So we're saying the timeline, we'll just throw it down here. The timeline starts in 1970 over here. So from 1970 to present of 2023, the Texas Star has always been, well, over here in the beginning, in the 80s. Texas Star was at the top of the flagship nation of the freaking amplifier creations, right? Well, now we get over here towards the 2000s, we refined the turd just a little bit better, right? We polished the pencil and we got our dunce caps out, and we've got it over here to where we're doing more with less. The thing that I always loved about the Texas Star is the quantity of heatsink, right? If we had this same amount of heatsink today, we would put 12 or 16 transistors on the same length of heatsink, almost double for this same piece of metal mass, right? There's guys out there like my friend Tech9 and many others that would take this and they would scrap 99% of this and they'd just use the heatsink off of it and make a way different amplifier. I always appreciated the fact of how much heatsink is underneath each one of these. And then if you add the fan kit to it, it gets pretty tough. What happened was, this Texas Star is no longer like the creme de la creme. They've fallen off. And it's not the construction of the Texas Star. Some of it is that. Like we see changes, like instead of using metal clads on the output transformers, they're now using, you know, surface mount SMAs, okay, or surface mount SMEs. So, I mean, the boards have gotten a little bit thinner. The wires have gotten a little bit cheaper. The capacitors have gotten a little bit cheaper, but the general design has stayed basically the same for the last 40 years. 5. As long as I've been alive. It would have been better if they could have taken and like flip-flopped, like put these 2 transistors here and then flip the board around and put 2 up here and then down here. That way they could be utilizing more of the overall heatsink surface. Texas Star is brilliant for doing the anodized heatsink. The anodized coating, there's a lot of studies that go along with the anodization coating on heatsink and aluminum about how heat will flow on aluminum as a transfer media. Aluminum's awesome. Copper is your best sponge. And I mean best sponge. Oh, hold on. We got a visitor coming in here. Hold on. Thank you, daughter. My beautiful daughter just came out and joined us. So copper is a beautiful sponge, right? It soaks up heat like there's no other. And it'll move the heat around more efficiently than aluminum will. Aluminum also is a great conductor of heat, but it trouts the copper. It just totally just, you know, where it's superior over the copper is its ability to transfer heat to the air. Otherwise, to take the heat that is absorbed in its metal mass and transfer those watts of heat to the atmosphere to be carried away. Okay. You can complement the aluminum and make it even more efficient at doing its job of moving heat around and transferring it if you anodize the heatsink. It's pretty cost prohibitive these days to do anodized heatsink. One, because the anodizing process adds a great deal of cost in the amplifier, and the way we stack the transistors today is different. We try to avoid putting everything in a row. I mean, we'll put everything in a row, but we'll try to make it in most of the board designs. We'll make it if the heatsink fins are running this way, we'll put the transistors this way. And we found after 2 rows, usually 2 are your 3rd row of heat transfer. It's like if you have your air going down and wrapping back, your last third of the heatsink never gets cool. So these transistors in this last row are always cooking. Well, Texas Star knew this, because let's face it, they've had smart people that have known way more about this than me, going back, long back before, you know, that we invented the wheel, you know. That's why they've got 2 fans pushing air this way and this way. So we never have a total absorption of heat. That's why I see guys, they'll block off, they've created little blockers that go across the front, and I'm just like, nah, it's a mistake. Yeah, it's fresh air that's getting blown in from the top, but this side will transfer all of its heat. You gotta remember, everything's stacked down about 3 ribs. So there's only about 3 ribs of this whole heatsink that's really getting utilized to its maximum. You can watch it on the FLIR and you'll see this little middle piece of the heatsink will be scorching hot, and then everything else will be, you know, 10 or 15 degrees cooler. If they were to put a copper spreader between these two, between the transistors and the heatsink, the copper will absorb that heat, and then it spreads, hence the term spreader, spreads the heatsink out and then transfers all of its heat uniformly, more uniformly. Not all complete, there's no such thing as complete, it's just more uniformly spread out to where the heat saturation to the fins is more uniform across, and it takes the pressure off the center. But this fan's blowing air down in that's cool. This fan is now having to overcome the CFM inrush of air from here, this being forced this direction, which is a bunch of drag. And then it's, okay, now we've got hot air coming in with cool air. The back end of the amp is still going to be cooking hot more than the front end of the amp. Does that make sense? And I think about heat in watts energy, right? So it's like, okay, so it's going to have X amount of degrees, and I know that the amplifier is going to only work at, if we're lucky and we can polish the circuit around a component to its 9th degree, you're going to get somewhere between 60 and 70% efficiency out of these transistors and doing their job, okay? So that means about 30 to 40% of the energy consumed through this clip now gets transferred into heat, and it's got to go someplace to do that job. hence the reason the big massive heatsink. That's why everybody wants to go to LDMOS, because we're talking the components are now 75, 80, 85% efficient, which means you can get more power out of less parts and have less heat that you have to try and scrub away. That's why everybody gets all excited about it. Unfortunately, the world that me and you and the rest of us all live in is dictated on by what we can buy and sell and trade into. And I honestly, I would love to believe that the world is ready for LDMOS tech, and there's a lot of guys that are very hungry for it. There is very few people out there that want to do their business differently. What I mean by that is turn their drive down. I built a 2-transistor LDMOS amplifier for a guy. I had it set up so that he could run his $1,600 striker into it, right? Big sticker on the front of it says 100 watts max drive. Big sticker on the back where the coax connector's at, 100 watts max drive. Covered that in the video. Show it doing all kinds of crazy watts over here on the workbench. Keyed it without the coax connected, shooting welding arcs out of the end of the coax connector. He gets it on his end and he has it for about a week. He calls me up and says, this thing works great. Then he calls me back and says, well, this thing's a pile of junk. I don't want it. And I'm like, why? He goes, well, the thing already blew up. Okay. So I get it back, and sure enough, the thing's got 2 transistors blown out of it. I'm like, well, this is something that you can weld with, right? You cannot overdrive it, but you can weld with it on the output. It doesn't care what the output is. Ruggedized, almost, quote, indestructible. I said, so what did you do? He goes, well, I was driving it with my striker and it was only producing about 1,900, 2,000 watts. I'm like, perfect. That's what it was designed to do, right? So he goes, I went and I grabbed my Connex and make a number up. I'm gonna just pull a number out of my ass. 3959 HPPS. I'm like, what? He goes, yeah, I put 400 watts of drive in that thing and it really got with it then. Oh, okay. See, inside those 2 transistors take 5 watts of drive apiece. So even with a 120 watt radio going in, I had to have an attenuator built into the front end of that thing. So with 100 watts going in, I'm throwing 90 watts away in heat, RF watts away in heat, so I don't oversaturate the 2 MOSFETs that are in this thing, right? Right? So he openly admits he killed it. And I said, okay, so you overdrove it. And he goes, nah, man, that thing makes the same power as an 8-pill. It should require the same amount of drive as an 8-pill, don't you think? No, I don't think. That's the reason that there's stickers all over the damn thing that says don't drive it any more than this, because it might produce a little bit of power, a little bit more power for a very short amount of time. What I'm getting at is guys are used to thinking in this way. The drive chain of, okay, so if we have 8 transistors, I need to take 2 transistors of the 22, like 2290 variety, 2 60 watt transistors to drive 8 120 watt transistors, right? It's very hard to get people deprogrammed from that. I've got over here on my own setup, I use a Cobra 29 going into 2 LDMOS transistors going into something bigger, way bigger. Those 2 transistors with just the 10 or 15 watts that are coming out of that radio, I think it's about 11.5, is more than enough to drive that amplifier to complete saturation and to do its job as a driver. A lot of these guys are used to having radio, driving this, driving this, driving this, driving this, driving this to get their end result. Just saying. I really like Sweet 16s, and I have. That's why I work on so many of them. I have since I was a little kid. I remember thinking that this was the shit. When I was on my road trip, I was in Virginia, and I was around Richmond, and the guys on the radio there, I kept asking, well, who's the big guys around here, blah, 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 blah. My buddy that was there, of course, he's one of the big guys. And I kept hearing about this guy, Duck Hunter, and I'm like, well, I know Duck Hunter. My friend Frank, I've known him since I was 14. I mean, he's known me since before I had hair around my ding-dang, right? I'm like, man, I can't wait to see that guy. Frank came to Boise, Idaho, because he was in the Army, and he showed up with an 8-pill transistor amplifier. The rest of us ducks were running around. We were something if we had a 30-watt radio, right? Maybe if we had a Texas Star 250. Oh my God, look at the horse wang on that guy, you know. Frank shows up and he's got himself an 8 transistor unit in the back of this little tiny pickup. So now here we are 30 years later, and I called him up and said, hey man, there's a whole group of us. We're gonna go get some barbecue at this joint. It's a literal joint on the side of the road. The guy's out back smoking pork and beef and stuff underneath a lean-to made out of tin. It's my kind of joint. Frank shows up and meets up with us, and it was so neat to be able to see him after 30 years. And you know, he shows up with his truck with his big antenna on it, and he's like, man, so what do you got in here? And I'm like, oh, I got a ride-around amplifier. He goes, oh yeah, what's that, like 8-pill? I'm like, nah, here's my 48-pill. It's the size of a suitcase carry-on. Oh, wow. It was just neat, because I remember when I was a kid being really impressed with just the fact that he had an 8-pill. And then here we are later on in life, and I'm like, yeah, here, check out my little just junker 48-pill I got. It was neat. But that was my first experience with the Sweet 16, was through Duck Hunter and seeing it literally with plumber's tape attached to the back wall of his truck. And he had 3 extra batteries in the bed and a stock alternator, and he was using I'll never forget this, a Radio Shack 2,000 watt meter. We didn't know. Fast forward now, we'd laugh at that, but we didn't know. Back then that was all right. I would never put 2,000 watts through a Radio Shack watt meter. I've had friends that have run all over the United States as truck drivers with that stupid shit set up in their truck, and they've never had a problem. Me personally, the bridge on the S, no way. No. But that was my first experience with one of these. And then to be able to go on in life and learn more about them and really understand how this thing works, and understand where if I inject this, it's going to pop out over here, and why, and you know how this controls that. And from the perspective of heat sink versus transistors, this is the most amount of heat sink you're going to be able to find underneath that number of transistors. And really, as a off-the-shelf, mainstream, commercial-built amplifier, that's a pretty scooching big relay. And there's a relay to drive that relay. What this relay does is it turns on the bias, otherwise switches 12 volts. That's all this does. Doesn't switch the receive, doesn't do anything, just switches the trail to 12 volts. Where have we seen that before? Anyhow, I digress, just saying. Let's rip this thing down. I gotta pull all the transistors out of this. This has got these little shitty caps in here. These little communist son of a bitches, when you go to solder on them, they fall apart. But we'll deal with that as we go. Let's rip the resistors out of here. We'll rip the transistors out. We'll get all these burned up resistors out of here. We'll wash it. We'll get it all cleaned up. We're going to put new transistors back in. We got to change out all the 1.8 ohm resistors. One there, one there, one there, and one there. Because every single time these transistors burn up, for a brief second, this resistor is exposed to a dead short. And I don't care if it's got 0 physical damage, 0. We pull every resistor and we test it. 9 times out of 10, instead of it being 1.8 ohms, it'll be like 1.5, 1.9, 2 ohms, 2.3 ohms. Because of this amp, the way it's set up, if those resistors don't have exactly the same amount of resistance to them across the board, it ends up showing up as an imbalance back here, and eventually stuff starts burning up. And the bias voltage gets too high, and then you pop some transistors, and then you're right back to where you started. Or heaven forbid, there's no physical damage to the resistor whatsoever, and it's now just wide open. So there's no resistance being applied to the circuit, and you've got 12 volts that shows up at each one of the input transformers, or at this input transformer. We'll say this resistor pops. 12 volts get dumped on here, and now you launch both the transistors out over a 30 cent or 25 cent or 15 cent resistor. So there's more to it than changing the pills out and putting a couple new resistors in here. You got to know the other parts to go look at. So, okay, we got that covered. Let's strip this down. Let's pull all the power wire out of it. Yeah. let's do our McNasty. Okay, so we got all the transistors out. These over here are the 6 that are fried. These are the 2 that are, quote, maybe good. Here's all the resistors. Here's the 2 combiners that went Hiroshima on us. It melted down to nothing here. Might be able to save that one. This one here is gone. It's all right, we'll figure that out. So what I did is I lifted, there's a 1.8 ohm and a 1.8 ohm and a 1.8 ohm and a 1.8 ohm resistor here. So this one here, so just to check what we're testing here, 0.2, 0.3 ohms. This has to read 1.6 ohms. There is no physical defect to this resistor. None. You'd never know by looking at the outside of this resistor that it's actually now a 500 ohm resistor. Okay, that's why we got to check all of these. This one here, no physical defect to it. It's completely open. This one here, no physical defect to it. Completely open. This here, no physical defect to it. Completely open. So now, let's change our test point. And we'll go from here to here. 1.6 ohms. Just from here to here. Completely open. Go from here to here. Completely open. And from here to here, completely open. But if I probe on the other side of the resistor, dead short. Completely open. Each one of these resistors has to have the same amount of resistance to them. That's what balances out our bias circuit. So it gives the bias its reference after it goes through our resistor. A lot of boxes we use diodes to do the same job. Texas Star, they use this little tiny 1.6 or 1.8 ohm resistor. So, needless to say, now we've got all this taken apart. I'll pull these out. And then we're going to get out the rubbing alcohol, the 91 proof rubbing alcohol. And we're going to give this thing a scrub-a-dub-dub and see if we can get rid of all the blast burned up schmoo. That's what's left of the leg off the combiner. Look at this. Just sitting like that. It's got so hot that it literally burnt the leg off. We'll get this whole mess cleaned up, and then yeah, we'll drop 8 new transistors in this thing and we'll go from there. So we'll be back. Staying alive, staying alive. It doesn't look like the same piece of shit it was when it came in. Now it's all clean with good, cute power wires and does everything on frequency. Got good distribution and a great power plug. Staying alive. Okay, so this is a 1,000 watt silicon peak, 1,000 an average bird, whatever you want to call it. Bullshitium for AM, because you know, bird 43 doesn't read on AM without a peak kit. 5 watt silicon reverse back from the bird 10,000 watt dummy load. We're going to use the D-Rail 955 Striker and a 5 watt slug between the 955 Striker and Little Texas Star. Little Texas Star that could. Okay. Let's check our bias. We're at 15.4, 15.5 on the input. Oh. 6.6. 6.6, 16.59, or 6.659. Here, get on there. 6.62. Okay, so they're all within tenth, 100ths, 1,000ths. They're all within 1,000ths of a, yeah. God bless them 1% resistors. Okay. So. Ha, 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 staying alive. Don't ask me why I got the Bee Gees in my brain this morning. I don't even listen to disco. I think disco's the gayest form of music that, well, not the gayest, but pretty rough. Okay, so, hello, 1, 2, 1, 2, 1, 2. I'm going to put about 130 watts of drive directly from the radio into this thing. We have an 18.5 foot non-reactive, nulled out piece of coax going from the watt meter to the input of this thing. We're not done yet, but we're close. I just want to show you that this thing's working. So we're 1,000 watts here. Hello, 1, 2. So well over 500 bird. So now let's take this up to 2x. So now when the needle moves all the way here to the right, that's 2,000 watts. The middle is going to be right there between the 40 and the 60. That's 50, or otherwise 1,000. 60's 12. In between that's 14, 16, and so on. Hello, 1, 2, 1, 2. Making about 500 bird. Nothing's getting too overly hot. Everything looks to be in balance. Staying alive. Hello, hello, 1, 2. Okay. Looks good on the pan adapter radio. Looks good on the frickin' spectrum analyzer. So I think we're good. Good. On the bird meter up here. Here. Okay. This is what we still got to work on. So we'll key the amp. We got no reflect. We got about 2, maybe wiggling 3 bars here. Hello, 1, 2. That's not bad, considering this amplifier is designed to take maybe 150 watt or 120 watts worth of drive, right? Peak. So what I want to do is I'm going to touch this capacitor. Just touch it. We're going to adjust the input tune just a smidge and see if we can get that to come down just a little bit lower for this guy. We're going to get to the towel of shame here in a minute. Okay. Let's get up here and let's see what we've done. I changed one capacitor. I went from 120 down to 100. That helped a little bit. 0 reflex still. Hello, audio. Hello, audio. Big difference. So now the input tune is perfect-ish, sorta. Results will vary depending on the length of coax you use for jumper. All right, let's look at it just talking through the amplifier. So now we're gonna pretend like the amplifier's in the trunk of your car or just tucked away out of the way. Hello, 1, 2, 1, 2, 1, 2. What we're wanting to show when we do this test, and I have to say this almost every single YouTube video. So when you go to watch the other amp builder videos, they don't take the actual video part as seriously as I do. They just want to get it done, get out of the way, and get on to the next thing that's going to pay them. I'm not that way. The RF's ability to go down from the radio up there down to here, otherwise from where you're using it, through the coax jumper, through the amplifier, and in this situation to a dummy load, but in real life this would be to a, your antenna. We want to show that the RF can pass through the amp like it's not even there. The reason I'm making a big point of this is because of this wire right here. Hopefully this will focus. If you look really close at this gray wire, you will see that this is Teflon-ish. Teflon. How hot did this combiner have to get, that's right here, to burn all the way through the Teflon and let it arc out. Okay. This wire that I was just holding up is the wire that goes from here, the input coax connector, to the relay. And it went by this combiner. The input and the output on this box literally shorted together at one point, which would be completely catastrophic. Hence the reason that we have this unbelievable pile of goodness over here. Let's take another look at this connector. You see how that's real even with the white plastic? This isn't Teflon, by the way. This is like PTFE or some BS. Come on, focus. Focus. Focus, there we go. We're having a bad day here. Pin's almost pushed all the way through. What we did is we replaced those screw pins with actual Teflon, just like the old school connectors. Teflon, well, the old school ones are Bakelite. We put brand new Teflon connectors on the inside, and then we replaced all the Teflon wire that feeds these connectors on the back side of the hookup here. These here. This is all brand new hardware. So we cleaned all the smoke, the shmoo, the burnt. Doggy does a lot of the inside of this thing. Upgraded everything he wanted to have done. The other thing is that the fans now will turn on as soon as the amp is turned on. So we have to make sure there's no labels on this. I mean, oh no, wait a minute. The stock label, it says fans still on here. That when you plug the fan kit in or out, and I point this out in every one of these videos when I modify these, is that you want to make sure that the amplifier is unplugged. Or just unplug it. Then you can plug your fan in and out. If this switch is on and you unplug the fan, you're going to blow this fuse. Now, on most stock Sweet 16s, they've got a wire that goes from here down to here on the board. We went ahead and saved ourselves of having a burnt trace, because this trace is like notorious for burning up. This one here. It'll first pop here. It usually pops back here on the board, and then it'll pop here, and then it pops here. And then the trace that goes from here, this positive rail, underneath the board over to here, will burn up. We went ahead and did away with that. We just went directly to the power wire bus here. So your 12 volt current that runs most of the amplifier is going to come from here, back through this blocking choke, then to this trace. Then it goes up to this fuse holder. This has a 10 amp fuse. Do not put anything bigger than that in here. That goes to this switch, and that in turn turns the amp on and allows the fan remote to work. Okay? If for some reason there's a short in the fan wires, or you plug it in and unplug it with the switch on, which, hey, I've been in this business for a minute, happens, you're going to blow this fuse. So just got to undo the case, put a new fuse in it, and you're safe. It's the guys that hardwire this, and then they do the fan upgrade, and then they call me, man, my shit won't turn on anymore. And I'm like, yeah, you blew the trace between here and there. Yeah. Okay. Yeah, everything's done. I went ahead and I blocked off the 2 holes in the back. These 2 have got metal, and then this third one, which was supposed to have a ground nut attached to it, which was one of the things they did way back. Went in and put a plastic insert there to keep the shit out of the inside of the amp. It's been washed, bathed, all new resistors on everything that was burned up, and it's working perfectly. Let's put the lids on it, let's get a sticker on it, and let's be done. But while we're here, I want to point out really quickly that we want to say thank you to the Patreons. They're the reasons that you guys have been able to enjoy this last 30-40 minutes of content with no ad interruptions. YouTube does not pay me for anything anymore. Like, nothing. Like less than nothing. At this point, I might have to pay them. So the YouTube guys the Patreon guys have stepped in and helped out YouTube. YouTube's going broke, by the way, if you guys haven't figured it out. That's why there's more ads than ever, and they're literally to anybody that'll sell ad time, or buy ad time from them. It's not like 3 years ago when companies actually advertised and gave a shit. Okay, so come check us out on Patreon. If you've ever learned anything from my channel, you think the content's worth it, come help us out. Come join us up. I want to say thank you to these guys. Well, let's get the tins on this. Let's get on with this show. Well, hello, 1 2 1 2 1 2 1 2 1 2 audio 1 2. We're working. I think we're going to end here. I'll say, gentlemen, thank you. I'm going to give a big shout out and thanks to Penta Labs, these guys, and these guys. Siglent, McMahon, Bird, Coaxial Dynamics, XS Power, of course. Every single one of you guys that tune in to give me a thumbs up and to hit the like button. I'm going to say just thank you. We're done. This is RO number 36, and it's in the repair books. Moving on. Gentlemen, we'll see you. Got a bunch more stuff coming. Click, click.